Okay, if you're watching this, you are in the right spot. What I'd ask that you do is pull out your notebook and make note of the things of significance along the way here. This won't be necessarily that long of a presentation, but you're going to take what we're talking about here and you're going to be directly applying it in an online lab that you're going to be doing immediately after this. Okay, so make sure your notes are ready, and you feel free to pause the video if it feels like I'm going a little bit too fast. And just make sure you get down that idea so that you can apply it on the lab immediately afterwards. Okay, so today we're going to talk a little bit about variables. Okay, and a variable is something that can change in an experiment. So that's going to be the definition of our variable here. And if something varies, it means it changes. Okay, but notice I'm being careful here. I say that it's something that can change in an experiment. It doesn't necessarily have to change. So we're going to identify 3 different kinds of variables today that we are going to be employing in the lab that we've got that's online immediately after. Okay, so hopefully you have that word defined. A variable is something that can change in an experiment. And the first type of variable we're going to talk about in an experiment is going to be what's described as an independent variable. Okay, so when you guys turn 18, you're going to be, some of you are going to be independent. You're going to go and live on your own, and nobody's going to be in charge of you. You are going to be in charge of what you do with your life. Now, some of you might be a little bit later, but let's just say at some point you're going to be independent. You don't want to be on your parents' couch when you're 45 years old. That's kind of not good. So what is an independent variable? It's what you as the experimenter is changing in the lab. Okay, so you're the one responsible for it. And what you do might have an impact on something else. Okay, so when you work with independent variables, it is crucially important that you only change one independent variable at a time. Otherwise, your experiment is mush. It means nothing because you don't know what you did that had the effect that you wanted. Okay, so one example of this is if you were studying health and diet. Okay, so let's say you wanted to see, and your hypothesis was, I believe that adding salt to a diet increases blood pressure. Your independent variable, which is what we're talking about right here, you are adding salt to a diet. That's what you're changing in the lab. And you are seeing whether or not this has an effect on the blood pressure. But this is your independent variable. Okay, that's what you are changing. Now, there are other things I could add. I could add fat. I could add soda pop. I could take away carbohydrates. But in this case, I want this to be the only thing that we're changing. So that is the independent variable. The dependent variable is, as its name suggests, dependent upon what you did to the independent variable. So in the previous one, the dependent variable would be the blood pressure. We're seeing if blood pressure depends upon adding salt to a diet. We're seeing if there's a link here. So another example of a dependent variable is, one thing you might notice this time of year is crickets chirping loudly throughout the sunset and evening hours. And one example of this is the number of times a cricket chirps per minute. And one thing that happens is that if it's warmer, cricket chirping is faster. And you can plot that data, and these are the number of chirps per minute. The number of chirps depends upon the temperature, okay? Not the other way around, okay? When a cricket chirps faster, it doesn't heat up the earth. Okay, so it's very important you know the order here. The temperature is the independent variable. The cricket chirping is the dependent variable. Another way to measure the dependent variable, or to figure out which one it is what you are measuring as the experimenter. You're trying to measure that and figure out what is happening to the dependent variable. Now finally, we come to our third variable today, and that is a controlled variable. Okay? And there are variables that could change but don't during an experiment. It's very important that you don't change them. Otherwise, as I suggested earlier, we don't know what is having the effect. Okay? So in our first lab experiment that I showed you, if we are measuring whether salt changes blood pressure, we can't also fool around with other parts of the diet, or we can't choose 80-year-old men and 15-year-old women. Okay, we have to keep things fairly consistent. We've got to control for those variables. In the case of the crickets, we should probably keep the same species of cricket, okay, in terms of measuring their number of chirps. So these are things we need to consider here. Here's a third example. Let's say you wanted to run a test to see whether the amount of sunlight a plant got, whether that influenced and affected the plant growth. What variables would need to be controlled? Well, in this case, you're seeing whether sunlight, that's my independent variable, affected plant growth, that's my dependent variable. But there are other things that might affect plant growth, and we want to make sure we don't confuse those with the amount of sunlight. So think about what type of variables might need to be controlled if we wanted to see whether it was only the amount of sunlight that affected plant growth. I want you to kind of think about what other factors might influence plant growth. And you may have come up with some of these. You could say, well, maybe I water it less or more. Maybe there's different types of soil. Maybe it's the amount of fertilizer that those plants get. Maybe I am using different types of plants. The important thing is, with the controlled variables, you have to keep these the same. You can't be messing around with these. They have to be getting the same amount of water. They have to be in the same type of soil. They have to be the same type of plant. They have to get the same amount of fertilizer. Otherwise, your experiment is basically meaningless, and you can't really say for sure whether or not it's the amount of sunlight that's influencing plant growth. So we're going to take these labs today, these three types of variables, independent, dependent, and controlled variables, and we're going to see whether or not those influence what we're measuring here today. So what we're going to be looking at today is actually going to be, we're measuring a pendulum and what affects a pendulum. So you're going to go to this website here. It's linked on your sheet there. All you have to do is type in PHET pendulum and you'll get this. Make sure it's the HTML5 version. And what you're going to do is you're going to click on this intro here, and you can change many things about this. You can change the length of this, you can change the mass of it, you can change how far you pull it off to the side, but you can change different variables, length, mass, how far you pull it off to the side. Those are three we want to worry about. We want it to stay on Earth's gravity. We want there to be no friction, okay? But you're going to want to kind of keep a stopwatch here going, and you're going to want to watch what's happening in terms of what is happening with the pendulum. So you're going to go to this sheet right here. This is the pendulum sheet. Let me get this over here for you. This is what you're going to be working with. And I want you to go to that website with the simulation, and you're going to try to see how these variables affect how a pendulum swings. It's going to be fairly self-explanatory, but if you have questions, please do not hesitate to email me or chat with me on Google Meet, and I'll make sure I can correct any and all any doubts that you might have. Okay, so if you could, for today, let's make sure that you take care of what you need to finish, and send me a question if you have one. We will talk to you later.